Hey, folks, please set up your notes just like this. I have this conversation going here and recording it just mainly for people that are absent. We're going to do this in class, or if you know you're in your advisory and you want to knock out the math homework, set up your notes and follow along in our discussion. I'm thinking of a funny line in October Sky, that movie that we watched just before Thanksgiving. And if you weren't here, just a little backstory. It's a small mining town in West Virginia, and in the 60s. So this father who's really a tough nut and tough on his son, and his son is rebelling a little bit and is not happy with his dad and how much time his dad and spends in the mine. He's a miner, a coal miner. And so the boy is complaining in the kitchen to his mom, and the father comes in and he says, you don't know what the mine means to me because you're just a boy. And I don't mean this in a really insulting way, but it's hard for you to grasp the magnitude of these concepts that we're talking about with circles because you haven't seen pre-calculus or you haven't seen calculus and all the uses for these topics in higher level math. So you have to trust me a little bit, and you're kind of a beginner in mathematics. And I know you don't feel like it, you're in 10th grade or ninth grade, and you've done a lot of math, you've done a lot of things, but putting it all together has not really occurred yet, which is somewhat unfortunate, but it can be overwhelming. So please trust me that these concepts that we're going to talk about are super, super important for higher level math. Okay. So I'm going to jam over to GeoGebra, and I had to do some investigating. How can I make GeoGebra do what I want it to do? You could see I had a tab open doing a little research there. And I've put a point on my arc. See that arc over here in red? So this arc right here, I just have some kind of random point here. Well, it's not random. It's in the middle of it. But I had to do that to attach a text. And the text that is being shown here, you can see is the same as the number right down here. So why did I do that? Well, this arc over here can be measured as an arc angle, or it can be measured as an arc length. Now, I want you to notice something. If I make my circle bigger, okay, see how the arc length gets bigger? Well, you might say, well, duh, Nelson, you just made the radius bigger. That makes the whole circle larger. So that would make the arc length bigger. But I want you to notice, I mean, this point is just along the angle bisector. So I got to move it out here to the angle or to the arc. The arc angle didn't change at all. The arc angle is measuring what really the central angle is. So this angle right here where the vertex is at the origin or it's at the center of our circle, I happen to put the center of the circle at the origin. I'm not sure I can move it. I'll try. Sometimes, yeah, see, it gets attached once I say, hey, let's put it at the origin. But my angle, the central angle, is the same exact measure as the arc angle. So if I move it over here, you can see I've got what's called a semicircle or half a circle. If I go past, now I've got what's called a major arc because it's bigger than 180 degrees. So this is a major arc. Here's a minor arc over here, 141 degrees. Now I have it set up in a very particular way where this is my kind of point of reference, my starting point, because that's what we do in advanced math. And when you go in this direction in advanced math, this is a positive angle, actually, the way that GeoGebra is doing it. I don't know if GeoGebra will do this. Check this out. If I go to the other side, this should be a negative angle over here. And it's not doing it. It's just measuring this major arc going this way. But this would be negative 45 degrees roughly, because you can see as we go all the way over, right, this is 360 degrees, getting close to 360 over there. It's putting the angle measure over here. That's because I marked kind of the center of the arc, right? So it'd be nice if I could drag that around, but I can't. I'll work on that. I'll work on my GeoGebra skills. So I go back here to 180 degrees, right? There's 180. Here's 90 degrees. Now, the drawings in the book are not going to be like this. They're not going to always have the starting point here and the ending point over here. They're going to have these angles any which way, but you have to understand this. This is the central angle. This is the intercepted arc right over here. So let me jam back over to my notes and let's look at a couple things and let's add a few things to our notes. So what did I draw? I drew a central angle, and I'm going to make it more like our textbook, okay? I'm just going to draw it in somewhat of a random place here rather than the starting side of my angle is over there, my initial side. I'm not going to make it in the positive x direction. I'm just going to make it like this. So this is my central angle right here. Okay, add that to your notes. Central angle. Okay, and it could be named with one single letter if there's only one angle there. Like if there's just an angle A, you could say the central angle is angle A, right? Now I'm gonna leave a little space here because I'm gonna add stuff to my drawing here. So let's put like a B over here and a C over here. And let's put another one like down here, a D right down here, okay? So if I drew the segment going down to D, now I've got 1, 2, 3, you might say 4. We have a lot of angles in here. So I cannot use one single letter. So I'd have to say angle B, A, C. That's my central angle. A is the vertex. It's got to be at the center of the circle if it's going to be a central angle. Now, the intercepted arc over here, sometimes you'll just see arc. Sometimes you'll see intercepted. That's the word I like to use. It's almost like a football word, right? Like if the pass is intercepted, it's picked off, it's hitting in a certain spot. So right here, this is intercepting this arc over here. And in GeoGebra, I had that shaded in red, right? So this arc right over here, you could call it arc BC. Okay, so that's called arc BC, and they'll put a little curve over the top. And the way I've got it set up right now, it's a minor arc because it's less than 180 degrees. So I'm going to put that less than 180. All right. Okay, let me change colors. Let's go for a major arc. So if we go major arc, we got to use 3 letters. Otherwise, people won't know exactly which arc we want. So I'm going to say this major arc, I'm trying to shade it. I'm not doing a very good job, am I? So I'm going to say BDC over here. So this is going to be my major arc, and I've got to put BDC with 3 letters, because if I just put, let's say, BC, somebody would be saying, oh, you're meaning this arc up here, right? So if you use 2 letters, you're saying an arc less than 180 degrees. If you use 3 letters, you're saying, follow me. We're going to go B, then D, then C over to here, okay? I'm going to make up some numbers here real quick. I'm not sure exactly what they are. I could pull my protractor out, put it on there for you. Maybe that's the way I should do this, but I'm not going to do that. I'm going to say this is 80 degrees over here. Just a rough guess. It kind of looks like it's pretty close to 90 degrees, but maybe a little bit less. You might disagree. So if that's 80 degrees, how would I figure out what the major arc is? Well, I'm going to take 360 and I'm going to subtract 80 from it. And that would give me, I think, 280 degrees, right? Oh boy, be careful here. 280 degrees, I think. So my major arc here, let me put it in blue. You would say the measure of BDC, you put the little M in front of the BDC, okay, to say the measure of arc BDC is 280 degrees, okay? Let's do the red one real quick right up here. The measure of arc BC, and you can put CB or BC, doesn't matter what order you put them in, is equal to 80 degrees. All right, and that's the same as the central angle. So let me put down this the same as the measure of angle BAC. So this kind of notation, oh, it's switching into some other mode here. Hold on one sec here, see if I can fix that. Okay, so BAC, all right, is my central angle right down in here. It's equal to the intercepted arc. These two things are equal to each other, right? Equal to each other. 80 degrees, central angle is equal to the intercepted arc. So let's see, what have I not covered? Well, a semicircle would equal 180 degrees. I don't have a semicircle, I don't think, in my drawing here. I don't want to clutter it up too much. The semicircle is 180 degrees. The arc length, that would depend upon how big the radius is. We're not worried about that today. So that's going to be tomorrow. I'm going to put that in here. That's going to be tomorrow's lesson. That's why we're doing 2 parts. The arc measure, well, we talked about that right up there. Like an example was the measure of arc BC. Okay. Hey, I hope that's enough notes to get you through the homework today. I feel like it is. There are a lot of problems, but a lot of them are pretty straightforward, pretty easy. Yeah, I think you're going to be just fine. with the exception, let me check that, the last 6 problems, I did throw a little arc length in there. I take it back. I did throw a little arc length in there on the last 5, is it? Last 5, excuse me. No, it's the last 6. And so let's just talk about arc length for just a second. And I only want you to do the last 6 if you feel like, man, I got it. I can figure this out. Okay. So if you had a radius of, let's say, 3, okay, how do I find the entire circumference of the circle again? So let's put that over here in part of our notes. The circumference is equal to pi times diameter, right? That's circumference. Circumference. All right. So that's what C stands for, right? So if my radius is 3, then in my example here, let's put down the example. We've got a radius equal to 3. That would mean that the circumference is equal to pi times 2 times 3, right? We need 2 of those 3s to get a diameter. So let me put another like 3 right over here, right? So that would be equal to 6 pi. Okay, so my circumference is 6 pi. Now let's say I want the length of BC. How long is BC? So they would say something like this: the length of BC. All right, so here's what I'm going to do. Well, it's part of 6 pi. It's some part of 6 pi. So let me put this down. It's what part of 6 pi? Well, it is 80 degrees out of 360 degrees. So I need to figure out what fraction of the circle I'm dealing with. And this you could just jam into Desmos, but I'm going to just reduce my fraction here just for practice here and just so you see what's happening. Well, 8 over 36, let's see, 4 goes into there, 2 times goes into there, 9 times, so I've got 4/9. Okay, I just divided 4 into both of these guys. Oh, dang it, let me undo that. Let me undo that. Let me try again. 4 goes into 8 2 times. I was thinking about the number 4. And 4 goes into 36 9 times, so I got 2/9 of 6 pi. And then, we could reduce this down. We get 12 pi over 9, right? 6 times 2 is 12. And 3 goes into here 4 times, goes into there 3 times. So we end up with 4 pi over 3. Now, let me just show you on Desmos what I would do. I wouldn't use GeoGebra to do the calculations. I'd go over to Desmos, and I would do 4 pi divided by 3. So I'm going to go 4 pi divided by 3, and then round to whatever place they want me to round to. Now, you might say, I didn't need to reduce that. I agree with you. I didn't need to reduce that fraction. I could have just taken 80 over 360. So I'm just going to hit the fraction bar first. 80, 360. The fraction bar, by the way, is just the divide by key next to shift, right? And then I'm going to take that times 6 pi, right? 6 pi. And I get the same exact answer. So you can just type this in right here into GeoGebra or into Desmos, into Desmos, type that in, and it will tell you what the answer is, right? So 4.19 if we round. So that's about 4.19 to the hundredths place. Hey, that video ended up being a lot longer than I had hoped. Thanks for following along with me. Tomorrow we're going to do more with arc length. Today is just like, at the end of your assignment. If you can figure that out, more power to you to make tomorrow's assignment a little bit easier. Hey, thanks for watching.